So as we continue here and we look into solving radical equations. Now, what that is a radical equation has the variable within the radicand. Example right here, where we have my variable appears within the square root symbol. So like any other equation, we want to isolate the radical because we're trying to isolate that term with the variable in it. And then we want to eliminate the radical. We're going to raise each side of the equation to the power equal to the index. So you think about what's the inverse of a square root would be the square. So that's what they're talking about there. And then we just go ahead and continue to solve it as we would any equation. So in this first example, in example 1, we have the square root of 3x minus 2 plus, the square root of 3x minus 5 plus 2 is equal to 6. Well, again, we want to isolate the variable. That's our first goal. So we take this 2 and we subtract it from both sides. So we end up then, now we have the square root of 3x minus 5 is equal to 4. Now, what we want to do here is that in order to get rid of the radical, right here it says we are going to raise each side of the equation to the power equal to the index. So you have to remember that when we have just the root symbol, that is indicating a square root. So part of that is, you think about that, this whatever's in here, x, is the same thing as x to the 1/2 power. So if we multiply it, raise it to the second root, then that would actually just be x to the 2/2, or just x. So that is the mathematical process of what we're actually doing just by raising it to the power and seeing how those exponents work together. So when you see the square root, if you want to, the inverse for me is going to say I square it. If you see the cubed root, the inverse would be to cube it. And that way we get to that isolation process. So that's what they've done here. They've squared both sides, and then so again the square and the radical just sort of simplify to 1, and then we get 3x minus 5 is equal to 4 squared, which was 16. And then you just do the same thing that you would with any equation. You continue to combine like terms and divide by the coefficient, and x is going to be equal to 7. Okay, so we just continue on that way. Now, so here in I'll just say we're going to talk about this, and that is exactly what I showed you here, is understanding that expression or a term or anything raised to the 1/3 power is the same thing as a radical, and that would be the cubed root. So knowing, well, what do we have to do? We have to isolate our variable. So we would add 9 to both sides. That would be our first step. Let's see here, add 9 to both sides, and then we get 12. And now, in order to continue, we would sort of divide by that coefficient, which would be dividing both sides by 4. And then your 4 divided by 4 becomes 1, and then 12 divided by 4 is 3. Now again, we have this radical, so how do I get rid of that? Or I'm sorry, we have this fractional exponent. Well, if I take and I multiply 1/3 times 3, that will cancel that out, and it will just become 1, right? So remember your power rule, when you have, a to the m raised to the n, we multiply, so that would actually be a to the m times n, one of those exponent rules that we covered earlier. So I know that cube 1/3 times 3 is going to be 1, so there we go, we got rid of that radical or that fractional exponent. And then again, we just do our inverse operations, and you have 2x is equal to 21. Divide both sides by 2, and x is going to be equal to 10.5. So it just adds one little step into the equation. One more thing that we can look at and examine for inverse operations. All right, so checking it, if we go ahead and plug that information back in, we can find out that, 2 times 21 over 2 is going to be the same thing as what? 21. 21 plus 6 is going to be 27. So you still have to do the exponent first. So 27 to the 1/3 power is 3. 4 times 3 is 12. 12 minus 9 is 3. So 3 is equal to 3. So it is a true statement. So this is that step that we always forget to do in our equations, is to check the answer. And when we're dealing with exponential equations and radical equations, then it's important that you check it, because when we talk about squaring and square roots, that can sometimes be a little bit more challenging. So now over here I have a lot of work going on. What this is what's going on here. They sort of skipped a lot of steps. How did I go from here to here, right? Well, what we did was we squared both sides, because we have this radical, we have this radical expression. So we ended up doing something like taking this side and squaring it, taking this side and squaring it. And that's what happened when I came down here, and I showed all the actual mathematical steps. Of course, squaring this side just made it to x plus 21. Here, though, we have the FOIL method, and that would become 3 times 3, 3 times negative square root of 6. Here we would have negative square root, I said 6, I meant x, negative square root of x times 3, and then negative square root of x times negative square root of x. So we start to see all of this stuff going on. So here's that distributive process that we just talked about. And then we go ahead and simplify, continuing to combine like terms, get this. So x plus 21 is equal to 9 minus 6 square root of x minus x. Minus x. Does that seem right? Distributing, we have... Okay, so yeah, that did not seem right. So if you notice, we have a negative times a negative is a positive. What happened here? Because I went from here to here. So I lost a sign there. So when we subtracted x from both sides, that would have canceled out, I believe. So you would have 12 is equal to negative 9, 9, so negative 6 square root of x, dividing both sides by negative 6. Shouldn't this be negative 2? All right, so now in order to get to, so we get to negative 2, right? That was clearly a typo on my behalf, because 12 divided by negative 6 is going to be negative 2. Now, so this is how we get to this point right here. And of course, I have that radical again right here. So if I square that side, I have to square this side. So x is going to be equal to negative 2 squared is going to be equal to 4. So again, x is going to be equal to 4. So we have the square root of 25. Is that equal to 3 minus 2? And it is not. That would be 1. That would be 5. So that is called an extraneous solution. Once we go back in and check it, it actually does not work. Okay? So just that's why we want to make sure when we are dealing with squaring and radicals that we definitely check our answers. So continuing on here, this radical equation is to the 1/6. So ultimately, when we get to that point, we're going to go ahead and multiply everything by the 6th power. And that's, let's see here. So first thing they did, again, isolating this, we want to subtract 8 from both sides. So that would give us 2, right? Negative 8, 10 minus 8 is 2. Then in order to get rid of this, right, I would want to multiply both sides by 3 over 2. Because when I multiply by 3 over 2, and let me make sure I remove that so it doesn't look like I was subtracting, multiplying, right? if I multiply 3 times 2, that is 6. If I multiply 2 times 2, 2 times 3, that is 6. So 6 over 6 is equal to just 1. So that's what happens. Those cancel out. And then this would be 2 over 1 times 3 halves. So that would be 6 over 2, or also known as 3. So when we get to this point, again, we've isolated that term, but we're going to raise it to the 6th power. If we raise one side to the 6th power, we definitely got to raise the other side to the 6th power. And then, so we end up, now the 6th power and the 1/6, they're going to simplify to 1. So 11x plus 14 is equal to 729. Again, subtracting 14 from both sides. And then 11x is equal to 715 dividing by 11, and x is equal to 65. Okay, so since x is equal to 65, the value of 65 does make the equation true when you plug it back in. Okay. Now, solving radical equations by graphing. Okay. So when we are solving these equations by graphing, you can do two different methods. You can use your related function, moving everything to one side of the equal sign, and then making basically y is equal to 0, so we can plug this into the graphing calculator and come up with the answer. The other way is to go ahead and set it up as a system. You have one side of the equation is one side of the equation would be, this would be my y1, this would be my y2. So there's just two different ways that you can set it up. So solving by graphing here, let's see here, find the related function. So we're going to subtract 9 from both sides. So we have 2 times the cube root of 3x minus 4 plus 1 is equal to 0. So now we would be able to put that into the graphing calculator. So that's what they've done. They've put that into y1, and then you can go ahead and view the graph. You can also now use the table. You can use that table to find the intervals where the 0 lies, looking for that 0, so we can calculate that 0. And it says here to find that 0, you hit calculate. Then one of your options is going to be 0. Hit enter, and then you can select your left, select your right, and then guess, which we've done in the past, and it's going to come up with that value on your calculator. Again, we've been doing this periodically a lot, actually, throughout this whole course, so being able to determine your calculation of functions and zeros and things like that should be commonplace now. Solving it using a system. So what we've done is we've taken, in this example, we have, this would be one equation in our system. This would be the other equation in our system. So we would have the square root of x plus 6 minus 5 is going to be equal to negative square root of 2x plus 1. And then when you graph these, instead of looking for where it crosses over the x-axis for the 0, now we look for a solution of a system, and we know that the solution of a system is where they intersect. So when you plug this in, you can look for the intersection under the same calculator feature, calc feature. And again, we've been doing this over and over repetitively over the last several months. So 2 months, okay. So looking at this, so that's looking at that. So here, the solution is the x coordinate of the intersection, which is about, in this case, about 4, right? 4.01, 4.02. So that's what we're looking for. So now when you plug these into the graphing calculator, it says use a graphing calculator to solve, and it says a systems of equations. So when you go to do this, you should have, your y1 is going to be equal to negative 4 cubed root of x minus 2, and then y2 is going to be equal to the 4th root of x minus 3 minus 6. And then once you do that, we're going to be able to calculate your intersection values. So when I put it in the calculator, this is what it looks like going into the calculator. And be careful here when you extend this radical. You want to make sure you don't get the -6 underneath the radical. When I did the calculate intersection point, so again, calculate the intersection, it's asked me for, like one curve, a second curve, and a guess. And the x value here is going to be my solution. It says round to the nearest hundredth, and 3 did not round up, so it went to 3.96. So there you go. That would be what it's going to look like in your calculator. Now, confirming solutions using technology. Let's see here. The square of the time it takes the planet to orbit the sun t is equal to the cube of the planet's mean distance from the sun a. This relationship can also be written as this. The time is equal to the square root of a squared, or a cubed. T is the measure of years, and a is the measure of astronomical units. It takes Mars about 1.88 years to orbit the sun. Use a graphing calculator to find the mean distance from Mars. So we have the square root of a cubed is equal to, they told me that it was 1.88. So when we solve that, we have the square root, so we would have to square both sides, and then a cubed is going to be 3.5344. And then now that we have a cubed, we would find the cube root of that. So the cube root of 3.5344 is going to be approximately 1.5233 when we put that into the calculator. Again, letting the calculator do the work for us. So then the mean distance from Mars, because that was the formula we were talking about, to the sun is about 1.5233 AU, which we said was astronomical units. Astronomical units, yes. So there we go. There you have it. And that's really that's several different ways to solve radical equations, systems, related functions using technology. So the calculator is going to do a lot for us as long as we know how to move and manipulate our numbers properly.